Okay, let's dive right into this. Welcome to another explainer. Today, we are focusing on something absolutely crucial: securing cloud applications with AWS Secrets Management. Imagine this. You just finished building a massive new feature, right? You push the code to GitHub. 20 minutes later, an automated bot scrapes your repo, finds your production database password, and permanently deletes your entire customer database. Now, why did that happen? Well, because you hard-coded your secrets and you really didn't understand where AWS applications should actually store them. So let me show you how to securely manage your application configurations. Every single application needs secrets to function. We are talking about database passwords, third-party API keys, and authentication tokens. But here is the fatal mistake developers make: treating these secrets like standard code and dropping them directly into their configuration files or environment variables. Listen, here is the golden rule. An application should never permanently hold a secret. It should retrieve it on the fly. Think about it like this. You wouldn't tape the combination of a bank vault right onto the front door, would you? Of course not. You would lock it inside a secure manager's office, and the bank teller would have to literally walk over and ask for it every single time they needed to open the vault. Well, in AWS, you actually have two secure offices to choose from for this: AWS Systems Manager Parameter Store and AWS Secrets Manager. Let's look at Systems Manager Parameter Store first. Parameter Store is your simple, highly effective configuration storage. It lets you organize your data into clean, logical hierarchies. So you can create a path like /production, /frontend, /API key, store the key as an encrypted, secure string, and then your code can just fetch it using the AWS SDK. It is incredibly cost-effective. Actually, standard parameters are completely free. But it is just a locker. It strictly holds exactly what you put into it. Now, here is where this gets really interesting. Enter AWS Secrets Manager. Secrets Manager is built specifically for high-value secrets. While Parameter Store just holds your password, Secrets Manager actively manages it. It features native automatic secret rotation, plus it integrates directly with AWS databases like Amazon RDS, Amazon Aurora, and Amazon Document DB. Now imagine this. Your company's security policy dictates that production database passwords absolutely must be changed every 30 days. If you use Parameter Store, you have to manually generate a new password, update the database engine, update the Parameter Store record, and pretty much pray you didn't cause any downtime. But with Secrets Manager, you simply configure a rotation schedule. Every 30 days, Secrets Manager triggers an AWS Lambda function in the background. That Lambda function securely connects to your RDS database, generates a brand new complex password, updates the database, and stores the new password. And the best part? Your main application never even notices the downtime because it always asks Secrets Manager for the latest password dynamically. So how do you actually implement this as an AWS developer? Well, if you have an AWS Lambda function that needs to talk to a database, you write a few lines of code using the AWS SDK, like Boto3 for Python. When the function executes, it makes an API call to Secrets Manager using GetSecretValue. Secrets Manager then decrypts the payload and hands it directly to your Lambda function right in memory. Or if you are running containers on Amazon Elastic Container Service, or ECS, you don't even have to write the API call in your code at all. You just map the secret ARN directly inside your ECS task definition. When the container spins up, ECS automatically fetches the API key from Secrets Manager or Parameter Store and safely injects it into the container's environment variables before your code even starts running. Now, this is where people mess up, and it is exactly how AWS will trap you on the DVA-C02 exam. You write the exact code to fetch the secret, you deploy the Lambda function, but your code immediately throws an access denied error. Why? Well, because you forgot that AWS is completely locked down by default. Just because your Lambda function and your secret are sitting in the exact same AWS account, that absolutely does not mean they are allowed to talk to each other. You must explicitly grant your compute resource permission to retrieve that secret. You have to attach an IAM policy to your Lambda execution role or your ECS task role that explicitly allows the Secrets Manager GetSecretValue action for that specific secret ARN. Without that exact IAM permission in place, your application is completely blocked. Think about that for a second. You are decoupling the password from the code, and you are entirely controlling access using IAM. If a junior developer downloads the source code to their local laptop, they literally cannot connect to the production database because their local IAM user doesn't have the permissions to read the secret, even though the code is identical. That is true cloud security. All right, let's lock this down. 3 rapid takeaways. Number 1. Never hardcode database passwords, API keys, or tokens in your source code. Your applications must fetch them dynamically at runtime. Number 2, use Systems Manager Parameter Store for hierarchical, low-cost configuration data, but use Secrets Manager when you need automatic credential rotation for databases. And number 3, your compute resources like Lambda and ECS must have explicit IAM permissions attached to their execution roles to successfully retrieve the secrets. Okay, one final warning before we wrap up. When you call the Secrets Manager API, you pay for every single request. So if you have a high-traffic application, please do not make an API call for every single user request. You need to use the official AWS client-side caching library in your code. It caches the secret in memory for a few minutes so you don't completely bankrupt your company making thousands of identical API calls per second. Now, doesn't that completely change how you approach application architecture?